going to explore the difference between dependent and independent events. So notice events meaning more than one thing happening at in this context. More than one thing is being considered. I'm going to use two different colors to distinguish between them. Okay. So we have, on the one hand, we have independent events. And on the other hand, we're going to consider events that depend on each other. How do you know an event is independent or events are independent? When the first event does not affect the second. How do you know the first one doesn't affect the second? If you notice that the total possible outcomes remains the same. So a die, it's always 1 out of 6, right? For any number, it's always out of 6. You can't change that. No matter how many times you roll, it's always out of 6. So if you draw a card, record your results, and you highlight this part, you replace the card before drawing another one, we would consider it independent, like someone drawing a card first, looking at it, putting it back in the stack, and then me walking to another student saying, hey, grab a card. It's still always 52 every single time. Okay? So you're replacing it. The total number of cards remains unchanged because you're replacing it. So that's one way to know these are independent. They're not going to affect each other. When you're rolling dice, right? When dice in particular, total outcomes for the second roll, or even the third, or the fourth, or however many you want to consider, is not going to be affected. Dice does not affect the total number of outcomes. I will say this, same with coins. It's always going to be out of 2. It's not going to matter whether I toss it once, toss it again. It's always out of 2. The total never changes. It's not affected. So those are independent. This is new. The dependent part is new because this is basically what we've been dealing with all along. Okay. So dependent events are different. The first event affects the total number of outcomes for the second event. How do you know that this is happening? Unless you observe it happening, you need to watch for wording, right? No replacement. So if it's dealing with cards or marbles or anything, snacks, my snack bin, right? As soon as you grab something and you eat it, the total number of snacks has gone down. Dill pickle, for whatever reason, it never changes. It stays the same. Nobody's taking dill pickle, right? But for the most part, a lot of the things that we're going to encounter in this section don't involve replacement, but read carefully. So cards, marbles, candies, snacks, if they're not being returned after being drawn, it affects the total number of outcomes of the second one. So I highlight quite a bit on this one. So if your teacher picks random students to come to the front of the class, the chances of you being picked next will increase because there's fewer left, right? So it is being changed, right? So that's an example of dependent events one more time. How does this affect our math? How does that affect our probability? Okay, so here's the example. I provided diagrams for you here. A bag of marbles has 3 red, 5 blue, and 2 green marbles. So we know that there's 10 in total. In this unit probability, finding the total is probably one of the first things that I would do. It says this, if a marble is chosen and not replaced, so I'm going to give this green again, okay, not replaced. What is the probability of drawing a red marble next? So this is the first one, first event, and because it's not replaced, it's going to affect my second event. So this right here is the second event. So what is the probability of drawing a red marble next? So we're going to go like this. Probability of red is going to be, how many did we have at the very beginning? We had 10, correct? But this happened. So I need to do something to my total. I'm going to get rid of a blue one. Get rid of one of the blue ones. So now you're left with 9. So 10 minus the blue one leaves me with 9 total. And how many reds are there still in this bag? Has that been affected by removing a blue one at first? No, there's still all 3 of them left. That reduces to 1 over 3, comma, 0.3333, or 33.33%. Basically, guys, the total is always going to be affected. If you're not replacing, the total is always going to be affected, always. Okay, so if a blue marble is chosen and not replaced, what is the probability of drawing another blue marble, another blue one? So blue has been taken. You want the probability of drawing another blue one. So this is first, and this is second. But notice it's only asking me for this probability of that second event happening. So I got to go probability of blue. I'm down to, I'm going to go 10 minus the blue one. I'm down to 9. I hope that everybody would agree with that. How many blue ones did I have to begin with? I used to have 5, right? At the very beginning I had 5 blue ones, but one of them has been removed. So I'm down to 4. So in this case, I had to kind of check for both of the numbers. Both numbers have been affected from the very beginning. The total, let me bring this up, some of you are looking over people's shoulders. The total has been affected for sure, and also the total number of blue ones. So originally you had 5, but this event also affected the total number of blue ones that remain. So if you look at the bag, the total has been affected and the number of blue ones has been affected as well. Okay. Next one. If a red marble is chosen and replaced, what kind of probability are we talking here if it's being replaced? I'm going back to the other color, to independent. What's the probability of choosing another red marble? Note, nothing changes. Total remains the same. So it's almost as if, why are you telling me that you picked that red one? Like, I don't care. Like, I don't care about this because since you're putting it back, it's not going to affect my second draw. Okay? So probability of a red one is going to be, how many do we have in the bag? 10, right? 10. And how many of them were red? 3. So it's just 3 out of 10. Or 0.3 or 30%. So off to the side of this paper and these 3 examples, I'm going to say on the side here that these here are dependent. So I'm writing on the margin here, dependent, And this last one is independent events. And just think about it. If something affects the other, then you are depending on the other, dependent events. If two events are completely not related, like it's not going to affect each other in any way, you're talking independent events. Okay? So, I'm going to ask you to go to page 50 and try this. Remember, this can be deck of cards. If you have 52 at the beginning, if you draw one and don't replace it, you're down to 51, and so forth. So go to page 50 and try those questions. And you may go to 51 if you feel like you have this all figured out. All right. So I'm going to post 50 to 54 for you to try. So for tomorrow, have the formula for expected value on your study sheet. And this, I will first go over a couple of examples before we do the AC on this one. Because it's fresh, I know that. And